All right, today we're talking about NumPy. This is the library that basically turns Python into a total beast when it comes to handling numbers. Let's jump right in.
Okay, so you've totally been there, right? You've got this massive list of numbers in Python, and you need to do something to all of them. You end up writing these clunky, slow loops, and you can almost feel your computer groaning. It's a super common problem. So what's the fix? Well, check this out. On the left, you've got the classic Python for loop, going through each thing, one by one by one. But look at the right. That's the NumPy way. It's one single, beautiful line of code that does the exact same thing, but it's ridiculously faster. I mean, this right here, this is why NumPy is an absolute game changer. So in this explainer, we're going to build up your essential NumPy toolkit. We'll start with how to pinpoint the exact data you want, then how to grab a whole slice of it, how to filter it like a pro, and then the really fun part, doing crazy fast math on all of it at once. All right, first things first, we got to start with the absolute basics. Before you can do any of the cool stuff, you need to know how to grab the one specific piece of data you're looking for. And that, my friends, is called indexing. Think of it this way. Every single number in a NumPy array has its own address, its own position. We call that its index. But here is the number one most important rule you have to burn into your brain. We always start counting from 0. Not 1, 0. And the way you do it? It's so simple. You just take the name of your array, add some square brackets, and pop the index you want right inside. That's literally it. This is your key to the kingdom for grabbing any single piece of data. Okay, let's make this real. Say this is our array of numbers. If we ask for whatever's at index 3, what do we get? Well, let's count it out. Starting from 0, remember? So 10 is at index 0, 20 is at index 1, 30 is at index 2, which means, boom, index 3 is the number 40. See? Simple. All right, so grabbing one thing at a time is cool and all, but what if you need like a whole chunk of your data, a whole range of numbers? Well, that's where slicing comes in. I mean, the name pretty much says it all, right? You're literally grabbing a slice of your array. The cake analogy is perfect. You're not just picking up a single sprinkle, you're cutting out a whole piece, from a start point to a stop point. And it's basically a 3-step dance. Step 1, you tell it where to start the slice. Step 2, you tell it where to end the slice. But, and this is super important, the slice goes up to but doesn't actually include that final number. Okay? Remember that. Then, step 3, you just grab your piece of cake. This is what it looks like in your code. You see that colon right in the middle? That's the magic slicing symbol. This is us telling NumPy, hey, start at index 1 and keep going until you get to index 4, but don't grab number 4. So if we follow that rule, what happens? We grab index 1, that's 20. We grab index 2, that's 30. We grab index 3, that's 40. And then we stop because we're not supposed to include index 4. And just like that, we get a brand new array with just that slice in it. Okay, now for something that is seriously powerful. What if you don't care where a number is, but you care about what it is? Like, you want all the numbers that are bigger than a certain amount. This is where we learn how to ask our data questions using filtering. Okay, the technical name is Boolean indexing, which sounds a little scary, but trust me, the idea is super simple. You just give NumPy a condition, like show me all the numbers greater than 25. NumPy then goes through your whole array and creates a secret list of true or false answers. The VIP list analogy is perfect. If a number meets your condition, it's true, it gets in. If not, false, it stays outside. So here's the really clever part. When you first give it the condition, my array greater than 25, it doesn't just hand you the numbers back. Nope. First, it creates what we call a mask or a filter. It just goes down the line. Is 10 bigger than 25? Nope, that's false. Is 20 bigger than 25? False. Is 30? Yep, that's true. And so on for the whole array. And now for the magic trick. You take that list of trues and falses, and you put it inside the square brackets of your original array. I know, it looks a little weird the first time you see it, but what you're really telling NumPy is, okay, show me only the values from my original array that lined up with a true in my filter. And boom, just like that, NumPy uses that mask and only the numbers that got a true pass through. In our case, 30, 40, and 50 were the only ones on the VIP list, so they're the only ones that make it into our final array. Okay, so we've learned how to grab our data with some serious precision. Now let's get to the real payoff. This is why we're all here. Let's see how ridiculously easy it is to do math on everything all at once. The official name for these are universal functions, or ufuncs for short. And their superpower is that they can take an operation, like adding, multiplying, whatever, and apply it to every single number in your array at the same time. No loops needed. This is the secret sauce behind NumPy's incredible speed.
Hey, remember that ugly for loop from the very beginning of this explainer? Well, this is how you do it in NumPy. You just take the array and add 100. That's it. It's so clean, it makes perfect sense, and it's lightning fast.
And look what happens. NumPy just blasts that plus 100 across every single element. 10 becomes 110, 20 becomes 120. You get the idea. All of it instantly.
Now, here's what you really need to understand. Our little array here is tiny, right? But this exact same code would work just as beautifully on an array with 1 million numbers in it, or 10 million. It handles that scale in a flash. And that right there is why NumPy is the absolute backbone of pretty much all data science in Python.
So let's do a quick recap of the tools you now have in your belt. You've got indexing, using those square brackets to grab a single item. You've got slicing with a colon to grab a whole range. You have filtering, using a condition to pick out just the data you need. And you've got ufuncs, like plus or times, to do lightning-fast math on everything. So there you have it. You've just learned the absolute core, the fundamental building blocks for doing some serious data work in Python. The only question left is, what are you going to do with it? What data are you going to tackle first? The power is yours now.